Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about some number series question. First of all, let us see about what is meant by arithmetic progression and how to print each and every element in a AP, right? Just see here. Let us take some example. First of all, what is meant by arithmetic progression? It is a number series in which we know the starting point, either an ending point, and we are given some value n, and we want to find each and every element with a particular distance. Like let us take the initial number is 4. Initial number is 4. It is denoted as a. Then what is the number of elements? It is 10. Let us take. Then the distance between two elements is, let us take 2. Now I can say the arithmetic progression for this set of input is 4 is the first number, then plus 2 it is 6, plus 2 it is 8, plus 2 it is 10, plus 2 12, 14, 16, 18, 20, 22. So this is my answer, right? So I have to print this all elements. But how to print this all elements? That's the question, right? So from this I can clearly say that we can just iterate through a loop until the value of n, then we want to print each and every elements, then update that element with the difference, right? How can I do it? Just iterate from 0 to n. Just iterate 0 to n. Okay, then just print that value in a, then update the value by what is the distance between two elements, right? This is my whole code. Let us see there. See here, a is equal to 4, d is equal to 2, n is equal to 10 for I in range of n. So that I have iterated from 0 to 10. That means totally 10 elements. 10 times this iteration will be running on. In each iteration I will print a value of a, then end is equal to space. Why I am putting end is equal to space? Because I don't want in next line, I want the output in the same line. That's why we have used this end keyword in Python. But if you are using C++ or Java, you don't want to use it. Fine. Then a plus equal to d. Just I am updating the value of distance in a, right? Then that's all about my code. Simple. Let me run it. Right, working fine. Now also we can do in another approach. We know in AP we have a formula like this. What does this formula denotes? It denotes the last element of that AP. Just see here, this formula denotes, if I give this set of input, it gives that formula gives this 22. Now I can easily iterate from where 4 to 22, 4 to 22, just jumping by two values. That's all. First initially 4, then 6, then 8, then 10 up to 22, right? But still, if you are using Java or C++, you use less than or equal to 22. But in Python, you want to use inside the range function as 23. That's why I want to put plus 1. You should be strong in syntax, right? Before solving any basic problems or any problems, you should be strong in syntax of any coding language, right? So that you can understand what logic have you used here, and you have to try to convert that logic into your code. Then only you can understand that you know the syntax of the programming language clearly, right? Now inside that, print I end is equal to just a space. This code also works fine. See here, fine. Now next problem, how to find sum of AP. So how to find the sum of that all numbers? So I can say I want to iterate to each and every numbers, then just do summation, right? Here in previous question we have found what, how to iterate or how to print this all elements, right? Just a small variation. Just take this print statement and put a summation variable. It may be yes or anything. Then just add the value of a and put initially the summation as 0. Why? Because initially the summation is 0, then adding this 4, then adding this 6, then adding this 8, all in this line, right? So I can do like this. Just see here. That same. A is equal to 4, D is equal to 2, N is equal to 10, S is equal to 0. But still, for I in range of from N to 0 minus 1, we can also put like what? N. Why? Because 0 to 10 means 0 to 9. The loop will iterate up to what? 9. It also 10 times. We can also use the previous approach also. Fine. And then S plus is equal to A. I have already told you, right? We want to add that A. Just I run it. See here, the value is 130. Now, we also have another AP formula like n by 2 into 2a plus n minus 1 into d. Right? So, let me explain that. See here, we have another formula. Just observe this. What is formula? N by 2 into 2a plus n minus 1 into d. This is a what? Summation of some AP numbers, right? AP series. So this is the sum of AP. So this is the formula. Fine. So see here, I have implemented that formula here and printing yes. This is so important. We can see why. See here, I just running it 130. Just observe this. Here we want to run up to n. Up to n. If I give you the n value is 1000, just assume you have to iterate from 0 to 1, 2, 3, 4, 5, 6 up to 1000. But if you use this formula, I can say by a fraction of a second, right? So that's the use of this formula. Then let us go to the next problem. Sum of n natural numbers. So sum of n natural numbers. It means the question states I will give some n value. Let us take the n value is 5, right? Then I have to take the summation value as 1 plus 2 plus 3 plus 4 plus 5. So this is the question states. So what is the answer? It will be 15. Fine. So this is the question states. Now how to approach this problem? The simple approach is I can say just iterate from 1 to n, then add each and every elements. Add every element, right? So what is the code? Code is just a 4 line or 5 line. Just see here. Just I take s variable or any variable, a sum variable. Just take a sum variable. Then for I in range of where to where? From 1 to n plus 1, because n is what? 5. We want to iterate to 6. That's why? Because the end value is always end minus 1. That's why we have written like this. It is just a simple syntax. S plus equal to I. Then print S. Right? Right? Now, let us see the code. See here, this is a code from 1 to n plus 1. Just I am adding each and every I value. Right? So this is the simple code. Now, let us see another approach. It is a optimal approach. Whenever I say optimal approach, this is the best solution we can do in terms of efficient in running time and also efficient in some space, right? Let us see that. Observe carefully. We already know what is the AP formula for sum of n, sum of some n AP terms. It is n by 2 into 2a plus n minus 1 into d, right? But observe carefully, we want only n natural numbers. Summation of n natural numbers. So it leads from always, it starts from where? 1. It always starts from 1. And what is the difference between each and every terms? It is always 1, right? The distance between each and every terms is 1. So I can say it also 1. But I don't know n, right? So I can apply this both in this formula. Just apply n by 2 into 2. Here comes 2, because 2 into 1 it is 2 plus n minus 1 into d, which is equal to 1. That's all. Now again simplify it. N by 2 into 2 plus n minus 1. We can take that n minus 1 plus 2, right, which is equal to n by 2 into n plus 1, right? So that I can say is equal to n into n plus 1 divided by 2. So this is the final formula. I can say this is the final formula, right? Just apply that formula. Just apply that formula here, right? So this is the formula for sum of n natural numbers, right? Let me run it. Same answer, 55. I have told you this formula because we want to use this formula in some other problems. Okay, let us see what are the problems, right? See here, this is the next question. Sum of numbers in a range. That means I will give you some range, right? You have to sum each and every elements inclusive to that range. What is meaning inclusive? Just observe. If I give the range is 4 comma 10, then what are the elements that are between 4 comma 10, and also we want to include 4 comma 10. So it is, I can say 4, 5, 6, 7, 8, 9 and 10. I can say like this. Okay, now on adding these all values I will get a result. What is the result? I think 49, right? So I can say I want to iterate from 4 till 10, and I want to keep track on a summation of each and every elements. Just I assign some variable is equal to 0, and each and every time I want to plus this with the iteration variable, right? So this is a simple solution. Just observe here. S equals 0 for I in range of L comma L, sorry, L comma 1 plus U, because if we want to iterate till 10, we want to give us 11 inside that range. Now S plus equal to I, print S, right? Let me run it. It is 49. Now we can also use another method. What is another method? As of now, we know what is the formula for sum of n natural numbers. So I can say if my range is this. Let us assume 1 to 10. This is my range 1 to 10. Then also I have another range 1 to 4. Let us simply take 1 to 4. Then what about the other remaining range? This range will be absolutely from 4 to 10. 4 to 10. Hence I can say I have found the range, right? But still we want this 4 to be inclusive. So I want to take the range up to what? 3. Fine. Now I can say summation of 4 to 10 is equal to summation of n natural numbers up to 10 minus summation of n natural numbers up to 3, right? So that I can get this whole range, right? So this is the formula. Fine, just substitute. See here, I have substituted. Just a second, I take the command. See here, what is the value of L? It is 4, but we want the summation up to 3. So just substitute instead of 4, just substitute 3. That's why. What is the formula for summation of n values? It is n into n plus 1 divided by 2, right? Then we want to do it for n minus 1. So n minus 1 into n minus 1 plus 1 divided by 2. This minus 1 plus 1 cancels, and n into n minus 1 divided by 2. I can write like this, right? That's why I have used L into L minus 1 divided by 2. Fine. Last is equal to U into U plus 1 divided by 2. So I have this is what? This is the summation of n natural numbers up to 3, and this is what? Summation of n natural numbers up to 10. Just minus it. Fine. Let me run it. Same answer, 49. So I can say that we can use that AP, that summation of each and every elements in AP series, and we can form a new formula for optimizing, or just to improve our approach, right? So these are all about the number series. Then we can see still more number series in upcoming videos. Thank you.